like we mentioned in our last video, the only indeterminate forms we can use is 0 over 0 or infinity over infinity for L'Hopital's rule. However, there are these other 4 types that we could use that are indeterminate forms. Well, 0 times infinity. Well, anything times 0 is 0, but anything times infinity is infinity. Infinity minus infinity. Well, which infinity really is bigger? It could be infinity, it could be 0, it could be negative infinity, it could be 22. 0 to the 0. 0 to any power is 0, but anything to the 0th power is 1. So what gives? In this one, 1 to any power is 1, but anything raised infinitely many times needs to be infinity or negative infinity. So here's the deal. We can find different ways to rewrite something from this equation and this form here. Not as much for the 0 to 0 and 1 to infinity. We can do it, it's just a little bit uglier. We're going to focus on these two as a possibility of what you would see on an AP calculus test. If you have one of these two powers, all we want to do is to rewrite the function to make it of the form that we can do, 0 over 0 or infinity over infinity. Then use the L'Hopital rule. So what I mean by that is, in this case, let's first start by trying to plug in. E to the negative infinity is 0. The square root of infinity is infinity. So I have a 0 times infinity, which is doable, but not by L'Hopital's rule. So that means, let's see if I can rewrite this. Well, a negative power means I could have it like that in the denominator, and then just the regular square root of x on the top. Now if I did this, I would have infinity on the top and infinity on the bottom. Now I can go and take L'Hopital's rule. So by L'Hopital's rule, derivative of the top is going to be 1/2 x to the negative 1/2, and on the bottom, still e to the x. So now, let's see here. Before I try to plug in, let me try to just simplify this a little bit, because it looks a little ugly. I got negative powers floating around again. I would have this 1/2 on top. I'd have a square root of x times e to the x on the bottom. Now if I plug in here, this becomes infinity, this becomes infinity, this is just some number. Infinity times infinity on the bottom is still infinity, so I have 1 over infinity, which gives me 0 as an answer. Now let's look at this one over here. I have 0 here. 1 over 0 is infinity. 2 over 0 squared is still infinity, so I got infinity minus infinity. What I want to do for these type is try to just make one big fraction. So I'll get a common denominator of x squared. To do that, I would need to multiply by this first equation by x on both the top and the bottom. So that means I'm now going to have on the top, I'll have x minus 2 and x squared on the bottom. And now I would look and see, well, if I do this, if I plug in 0, 0 minus 2 is negative 2 over 0 on the bottom. So my answer here actually is negative infinity. And you'll notice sometimes you don't even have to use L'Hopital's rule just by rewriting it in this form. If you needed to, you would have then done L'Hopital's equation, L'Hopital's form, L'Hopital's rule if you had 0 over 0 or infinity over infinity. In this case, we didn't even need to.